Hello. So my name is Trevor Robbins. I'm Professor of Experimental Psychology and Cognitive Neuroscience at the University of Cambridge. I'm actually the Head of Department of Psychology, Director of the MRC Wellcome Trust funded Behavioural and Clinical Neuroscience Institute. And one of my claims to fame, if you like, is as a co-inventor of the CANTAB battery. It's a Cambridge Neuropsychological Test Automated Battery. And I'm going to begin by just telling you a bit about the history of CANTAB, how the idea formed from an early grant that was awarded to us by the Wellcome Trust. Yeah, well, I've always been interested in applying our science to human clinical disorders. I did an early study on Parkinson's disease during my PhD thesis, but then I was really sucked into basic neuroscience for quite a while, until 1983, when we saw an advertisement the Wellcome Trust put up for a major award in mental health disorders, translating essentially basic to clinical neuroscience. So we said, oh, we'll apply for that. So we applied to do human work as well as animal work in Parkinson's disease and Alzheimer's disease, which were obviously very important concerns even then. And we took the challenge of translation of the animal work to the human work by asking the question, how valid is it to do behavioural experiments with animals and then extrapolate the findings to humans? And to do that, really, you've got to try and ask the same kinds of questions of your experimental animals and humans in the same kind of tests. Now, we got the idea for using touch-sensitive screens controlled by computers, partly from a colleague, David Gaffin, at Oxford, who'd been innovating in this use with monkeys. And what he'd found is that monkeys find it much easier to make associations of stimuli with rewards and responses if they actually touch the stimuli involved. And that resulted in much greater learning and a bit of fun actually for the animal. They enjoyed these types of tasks. So we thought, well, perhaps we should do this in humans. And when you think back, this is quite innovative because, of course, nowadays we have the fantastic iPad technology, which CANTAB has utilised. But then there were great clunky touch-sensitive screens which you strapped on to your computer video monitors, and you know, just sometimes you had to belt them on again, they fell off or whatever, and it was all very difficult really and cumbersome, but nevertheless we persisted with it. And we tried out these methods in patients. We were worried with Parkinson's disease about their movement problems. Are they going to be able to make these responses? Actually, that was completely unfounded, because they were readily able to point to stimuli. We of course included some tests of sensory motor function to check they could do it properly, and they could. And they found it quite easy to get a response out. And also with the Alzheimer patients, I mean, this is a very dramatic experience for us. Barbara Sahakian, of course, was at the Institute of Psychiatry, and she had access to patients with Alzheimer's disease through the section of old age psychiatry with Raymond Levy. And I remember the first time we tested an Alzheimer's patient in a pilot kind of way with John Evenden, who was working with us developing CANTAB. And John wanted to do a matching to sample task, and he thought that they could tolerate really quite long delays. But we found, to our astonishment, that some of these people couldn't even remember a stimulus for as long as 4 seconds. So we had to make the test really simple. And that's when we really introduced the idea of graded difficulty. You see, having worked with animals, we know the kind of cognitive problems that animals can get into. You know, things we take for granted, they don't. And they have to do all sorts of quite important atomic kind of cognitive functions in order to even the simplest behaviour, you know, to approach food or something like that. It's quite a complicated event for an animal. And what we were finding is that in patients with Alzheimer's disease, they were reduced sometimes to the same level of cognitive performance. So again, things that we would take for granted, they couldn't possibly, because they were unable to hold online information for very long. So that was another very important principle that we introduced, that we were going to have graded difficulty, so that we could go all the way potentially from patients up to healthy volunteers. Now we know that's a very difficult brief actually, because if you make the test too easy, of course, healthy volunteers will score 100%, and that's not very useful. So you have to be able to make the test progressively more difficult as well to get the whole range of performance.